Hello students, welcome to IMS Gate Academy. In the last session, I explained the problems on three topics such as diode circuits, BJT and feedback amplifiers. In today's gate score booster session, I am going to discuss problems on operational amplifier and also MOSFET. From these two topics, I would like to do number of problems. Understand now. But you try to practice before, but I give answer. You need to do the question and you need to message the solution also for the question here now. Okay, I'll start the problem now. The first question, very good question. But I will see how many number of students are going to do this question. Initially, I want to give every question I want to give initially in the hands of the students. They need to give answer. Otherwise, I will not do this question. Understand? First, your answer is more important now. Okay, I will give you time. You please try to tackle this question. But I am giving 2 minutes. Please try this question. Yes, time up. I didn't receive solution from many students. It's a very good question. One source on the gate is a gate 2024 NITs paper asked. What is asking the problem? Please check it. I will do here. But what is given problem? First, we can see that problem. In the circuit below, the op amp is ideal. Here, the operational amplifier is given ideal. If the circuit is to show sustained oscillations, the respective values of R1 and the corresponding frequency of oscillations are dash. Is asking to find the R1 value and also is asking to find the frequency of oscillations. Sustained oscillation, that sentence very important now. Sustained oscillations. The circuit shows sustained oscillations. Sustained oscillations you will get only from the oscillators. not from the any other circuits. Sustained oscillations you will get now. That means amplitude will be maintained same. In that case, we need to apply the conditions which are given in the oscillator. They were nothing but the Barkesian conditions, you know very well. By using the Barkesian conditions only, we can tackle this question. Understand my point now? What are the Barkesian condition? Loop gain must be unity. The first Barkesian condition. That is nothing but A into B, beta, A beta equal to 1 is the sustained. What are sustained oscillations to get? First Barkesian condition I can say. The second one, the total phase shift in the given oscillator is 360 degree required. Our phase shift must be 0 degree or 360 degrees required. These two must be obeyed. Without obeying these conditions, you will not get the sustained oscillations. Understand? Anyhow, here given sustained oscillations now. But how we can get here now? But in this circuit, this is the operational amplifier. For the sake of getting the gain, we are going to use op amp to get the required gain. This is nothing but the feedback network. This is nothing but the feedback network. The feedback network onwards, we can get the required frequency. That is very important now. So here I would like to denote certain names here like this now. This point, this voltage I have taken V0. From this circuit I will get the V0. Output of the op amp is V0. And here I got the feedback network. This voltage I want to take it as a VF, feedback voltage. Voltage across the capacitor. This is the feedback network, this is the operational amplifier. Separately I want to draw this feedback network. VF by V0 is nothing but the beta value. VF by V0 is nothing but the beta value. You will get here now. And this potential is nothing but the again VF only, same VF you know. And this point same VF is possible. It is a non-inverting operational amplifier. From the non-inverting operational amplifier, you will get the gain of this operational amplifier 1 plus R1 by R. That is the gain available from this operational amplifier because it is a non-inverting operational amplifier. I say initially we can find the gain of this op amp A, but I say this is A. This is A. A value is nothing but 1 plus R1 by R. This is the gain we can get from the operational amplifier. This is a non-inverting. So this circuit I want to redraw again to get the required value. C in farads possible, R in ohms possible. But I want to get in S domain because all are required in ohms only. In that case, I can draw the circuit like this. This is the capacitance of the capacitor, 1 by Cs. From the Laplace, you will get 1 by Cs. Now, you will get in ohms only now. Resistor is connected to the ground. This is connected to the ground. And one more resistor, R is connected here. This is R. And capacitor also connected to the ground. Capacitor also connected to the ground. I can take 1 by Cs again. And this voltage is nothing but the VF. We know very well. VF. This voltage here I want to take it as a V0. V0 I want to take here now. Beta is nothing but VF by V0. But in this network I want to simplify to get VF by V0 value. How we can simplify? You please watch. This is a very important point. This is open circuited, this circuit. Thevenin's theorem I want to apply. This circuit is the open circuit. The equivalent Thevenin circuits for this network I want to draw. If that means VTH and RTH required. They were all connected in series to the what now? R and C itself now. But I want Thevenin's equivalent circuit for this network. I want to find what is VTH at first. When the view is made, voltage across this R is to be taken as a VTH only. This is VTH, voltage across R. VTH is nothing but the V naught into 1 by CS divided by R plus 1 by CS. R plus 1 by CS I can write. On simplification, I can get V naught by 1 plus RCS I can get. 1 plus RCS I can get here now. VTH means V naught into, 1 by CS, voltage across R only required here now. Voltage across, just wait. Here I want voltage across R, V naught into R by R plus 1 by CS, we can write it now. But on simplification, I can get V naught by 1 plus RCS, take LCM. The CS, RCS, you will get in the numerator. This is RCS. That is the Thevenin's voltage. Please note down this Thevenin's voltage. You note down this Thevenin's voltage. And also, I want to find RDH for this network. When the view is made from here, short circuit the what now voltage and the view you have to make this side. R and 1 by CS are in parallel. Apply the parallel condition and get the ZTH I can find. ZTH or RTH, any one we can write. ZTH is nothing but this and this parallel. R into 1 by CS, R into 1 by CS by R plus 1 by CS. R plus 1 by CS. 1 plus 1 by CS possible. R plus 1 by CS. It is a non-numeric question in the gate. Be careful. R into 1 by CS by R plus 1 by S. On simplification, I can get R by CS cancel here now. 1 plus RCS I can get. Please note down this. Please note down this first. Please note down this. Now, you can draw the equivalent circuit for this. Thevenin's equivalent circuit I can draw to find VF by V naught here now. How Thevenin's equivalent circuit is to be drawn here? I can draw like this now. This is VTH. VTH equal to, you got the value. How much? V naught into RCS. V naught into RCS divided by how much you are having? 1 plus RCS we are getting. 1 plus RCS. This is VTH value. But a Thevenin's equivalent circuit we can write VTH in series to the what now? ZTH is must. This is ZTH. We got ZTH. Already we are getting now. R by 1 plus RCS. R by 1 plus RCS. R by 1 plus RCS. That is connected to R by 1 plus RCS. That is connected series to R and C. R, there is R here. The resistance R is given. And also here given one capacitor. This is 1 by CS. The VF is to be taken here. This is VF. Correct? VF R 1 by CS. Now perfect. That is the final equivalent circuits now. By using this network, we need to find what is VF. By using the voltage division formula, I can find voltage across this capacitor. 1 by CS I want to find out. Voltage across 1 by CS. So VF is nothing but supply voltage V0 RCS divided by 1 plus RCS here. That into 1 by CS here, 1 by CS divided by addition of all the impedances now. ZTH plus R plus 1 by CS. ZTH is nothing but R by 1 plus RCS, 1 plus RCS plus R plus 1 by CS I can get, plus 1 by CS. Yes, I am getting this value. It's a very important question. Same question asked 2 times in the gate, understand my point, in ECE. But here you take LCM and find, because our aim is to find VF by V naught is required. That is a beta value. I want beta value. Beta is nothing but VF by V naught I can write. Very slowly I am going now, because every student must understand. After LCM, 1 plus RCS cancel. After LCM I say. Here the CS cancel. Still what is left here? No, CS, this CS will be cancelled. I can write RCS, I am having here. RCS, CS after LCM. 1 plus RCS after LCM cancel. Still what is left? LCM 1 plus RCS into CS. Here I will get RCS, I can note down RCS plus R into CS, RCS into 1 plus RCS, 1 plus RCS plus 1 into 1 plus RCS, 1 plus RCS I can get. The gate question for 2 marks. RCS into 1 plus RCS, and still we are getting 1 plus RCS. But I can simplify this RCS by what I will get here. This is 1 RCS into RCS whole square, RCS whole square I have written here now, plus how many RCS are there? 1 RCS, 1 more RCS, 1 more RCS. 3 RCS I am having here now. 3 RCS I can write. What constant is there still? Any constant is there? Yes, plus 1 is there now. Plus 1 we have. But here what I wish to do, numerator and denominator I want to divide by RCS. I say I wish to divide here numerator and denominator by this term, same RCS. This by RCS I have taken here now. After division, what I will get? Beta equal to, I can get RCS by RCS 1 itself. I will get here now RCS whole square by RCS, 1 RCS I will put. 1 RCS I can get. 3 RCS by RCS, I will get 3. Still 1 by RCS I am getting here now. 1 by RCS. This is the beta value. This is the beta value. Please note down this. Please note down beta. This is beta value. Here my aim is, but here the sustained oscillations are available from this oscillator. Sustained oscillations means we must apply the Barkhesian condition. I means A beta equal to 1 is applicable here now. By using that condition only we are going to get the required results here now. But we know that, but here we know here clearly now, I'll write here now otherwise now. A beta equal to 1 we know very well. A beta equal to 1 means A equal to 1 by beta. A equal to 1 by beta. A equal to 1 by beta means A value we know already given. 1 plus, what is given already? What is given already? 1 plus R1 by R. 1 plus R1 by R. 1 plus R1 by R is given. That is A value. 1 by beta means just to reciprocate, RCS. RCS means S equal to J omega, I substituted. In J notation, I want to get now. 3 goes to numerator. Plus 1 by RCS, S equal to J omega. j I want to get in the numerator, multiply and divided by j. Finally, I will get minus j by something I will get. 3 comes to numerator minus, when it goes to numerator, 1 by RCS, S equal to j omega, multiply and divided by j. J by RC omega I can get. But I want to compare real and imaginary parts to get the answer. Comparing real part. Comparing a real part. If the real part is compared, you will get the what now? One value. Real part means 1 plus R1 by R. 1 plus R1 by R. 1 plus R1 by R equal to 3. And R1 equal to what you will get? 3 minus 1, 2. R1 equal to 2R is possible. R1 equal to 2R is possible. Yes, we are getting R1 value. R1 value we got. But I want to compare imaginary parts. Comparing imaginary part. Imaginary part, IP I have taken out, imaginary part. This side imaginary part 0. This side I got RC omega minus 1 by RC omega. I can write. So what I will get here? What I will get here? Please watch. Here RC omega, omega square equal to, you will get here now directly. 1 by RC square. 1 by RC square I can get here now. RC square, omega equal to 1 by RC, omega equal to 2 pi f. 2 pi f equal to, what I will get? Omega equal to 2 pi f. 1 by RC I can get here now. And finally, I can get frequency f equal to 1 by 2 pi RC is available. 1 by 2 pi RC. The final answer we are getting, what we are getting here now, finally answer, R1 equal to 2R we are getting. R1 equal to 2R we are getting. And frequency equal to 1 by 2 pi RC. F equal to 1 by 2 pi RC. 2 pi RC is available. So which option is correct here? You please check it. Please note down this first. Please note down this. And which option is right here? You check it. Sorry. Which option is right? Please check it. 2R 1 by 2 pi RC. Yes, option F is correct. EF, in the place of A, B, C, D, E, F, G, H is given here now. So which option is correct? F is correct here now. F is correct in this particular problem. F is correct. R1 equal to 2R and frequency equal to 1 by 2 pi RC. I hope you followed. It's a very good question. 2 times saw same question in the gauge. Yes, we can try for the next question here now. We can try for next question. Anybody can do this question without my help? Any student can do this problem? But I want to give you some time. Please tackle this one. I want to give you time. Just to take 2 minutes and complete this question. Yes, time up here. But I am not getting solution from any students. But you must try, this is more important now. For your practice, we are doing these questions now. We are giving every one of the question for the sake of the practice of the students only now. So your effort is required initially. Understand my point now. Without your effort, no use. But what is given in this particular problem, you please watch it. You will understand clearly now. You will understand. In the circuit shown below, all the components are ideal if V1 or Vi. V1 is 2 volts. The current I0 sourced by the op amp is dash milliamperes. Is asking to find I0 value. I0 is nothing but current passing through this side. This current is required. But if the problem is given, you need to identify at first the given op amp is ideal or not. The problem clearly given, all the components are ideal. So here the op amp is ideal, no doubt. How to get this I0 value? What way we can find I0 value? What is the way to find I0 value? To find the I0, what you need to do here is, I'll explain, please watch. We need to find this current at first. We want this current. This is nothing but the I. This current is I. But op amp is ideal. If operational amplifier is ideal, is it passing any current this side? This side no current will flow. The reason is op amp can have input impedance of infinity for ideal case. If input impedance is infinity, the current passing through this side is approximately 0 value. 0 current passes this side. Whatever the current passes this side, same current will flow this side. I or IF, same I we can put, no problem. Same I will get. If this current is I0, this current is I. But I have taken the load current IL. This is IL I have taken. And this node voltage, I want to take it as a V0. I wish to take it as a V0 value. So I0 plus I equal to IL. I0 plus I equal to IL. IL. What is I0? I0 is nothing but IL minus I. IL minus I. So if you know the values of IL and I, you can get answer very easily now. You know very well. This voltage, what is this voltage? You know very well. In the problem it is given V1 is nothing but the 2 voltage is given. This voltage V1 or Vi, it is given 2 volts. V plus is 2 voltage, V minus also same 2 voltage you will get now. And V plus and V minus same value. How V plus and V minus are equal values? Everybody know very well. How it is equal? For ideal case, everybody knows. For ideal case, everybody knows. V0 is nothing but output voltage of the what now? This op amp. AD into VD, general formula. AD into VD is applied for the V0, for the ideal case. But V0 is nothing but AD into VD. VD means difference of this voltage. This is a V plus, this is a V minus, we can assume. V plus minus, V minus. V minus. V plus minus, V minus you will get generally. V plus minus, V minus I can write. VD value, difference V plus minus, V minus. V plus minus, V minus is nothing but everybody knows V0 by AD. V0 by AD. But everybody knows ideal case AD value is nothing but infinity. An ideal op amp can have differential gain of infinity. Then V was something by infinity 0. V plus minus V minus equal to I can get 0 only now. So finally V plus equal to what I can get? V minus only. No doubt V plus equal to V minus. That only we can say virtually ground concept, otherwise you can say. Otherwise you can say anyhow V plus equal to V minus. V plus is a 2 voltage given, same V minus also same voltage, 2 voltage possible based upon that condition. Now here this current I is required. The value of I is needed in this particular problem. How to get I? I is nothing but 0 minus grounded here now. Grounded means 0 minus 2. 0 minus 2 divided by resistor. What resistor we have? 1K. This can be taken as a minus 2 milliamperes of current. This current is minus 2 milliamperes. The fact you know current always passes from higher potential to lower potential, must go this side. For our convenient purpose, this current equal to this current I have taken. Conventional direction we know. In that case, I am getting minus 2 milliamperes. Yes, we are getting I. I want here V0 also. Without V0, I cannot find I2 value. Without V0, I cannot find I2. How to get V0 here? How to get V0 means the I equal to 2 minus V0 by resistor. Ohm's law I want to apply. The current is nothing but difference of voltage by resistance, because current through the 1K I want to find. That is my aim. So current through the 1K is nothing but I equal to 2 minus V0 divided by how much? 1K. 1K. The problem I value we know, minus 2 milliamperes. That equal to 2 minus V0. My aim is to find V0 by 1K. 1 into 10 power 3. But I want to find what is V0 here now. What is V0? What V0 I can get now? Here the value what I will get here now. First we check it. On simplification what I will get here now. 1, 2, 10 power 3, 10 power minus 3 cancel. I am getting this side minus 2. 2 minus V0 I can get. So finally here now V0 equal to what? 2 plus 2. That is a 4 voltage I am getting. V0 is nothing but the 2 voltage. Please note on this. V0 is nothing but 4 voltage we are getting. So why this V0 is required? To find the I2 value. I2 equal to we can say V0 by 1K. V0 by 1K. V0 is nothing but the 4 volts. This is a 1K that can be taken as a 4 milliamperes. 4 milliamperes. Now I can find I0 plus I equal to IL. I0 plus I equal to IL. But I want what is I0? I0 is nothing but IL minus I. What is IL? IL we are getting V0. I2 is not IL only, is it not? This is IL. We can put IL. IL equal to how much here now? IL is a 4 milliamperes. 4 milli. I is nothing but minus 2 milliamperes minus plus 2 milli. The finally this I0 is nothing but the 6 milliamperes possible. 6 milliamperes possible. Please note down this. Answer is 6 milliamperes. We can write directly I0 is nothing but 6 milliamperes. That is the solution. Like that we need to tackle. Yes, I want to give one more question. I wish to give one more question. You please try this. This is the next question. But I want to give you 2 minutes. Please try to tackle this question. 2 minutes, just enough. Yes, time up. Now required solution for this question. But how to get the solution for this question? What is given problem? What is asking? What work is required from our end? We can see. That we can see. The following signal Vi, the following signal Vi of peak voltage 8 volts. This is the signal given. Its peak value is nothing but the 8 voltage is given. The 8 voltage is applied to the non-inverting terminal of ideal operational amplifier. But this is given to non-inverting terminal. Non-inverting terminal means for the positive terminal, this Vi is connected here now. Vi is connected to the positive terminal. Non-inverting terminal of an ideal op-amp clearly given here now. The op-amp is ideal. The transistor has VBE equal to 0.7. Base to emitter voltage of this transistor is 0.7 voltage given. Beta given 100. Voltage across the light emitting diode, here connected with a light emitting diode. The light emitting diode BLED is given, light emitting diode voltage 1.5 voltage, VCC 10 voltage here now, minus VCC minus 10 voltage given. That means input side waveform is nothing but this Vi waveform is nothing but this such a shape of the waveform. You should not give more than this waveform. The problem clearly given. The input is given from here to here only, that is Vi. Maximum amplitude is nothing but the peak voltage is nothing but the 8 voltage only. The number of times the LED glows is because of giving this input signal, how many number of times LED glows is required in the problem. Is it 1 time? Or 2 time, or 3 time, or 4 time, we need to identify. How we can do this question? It's a very good question. But in the problem, you have to understand one more point clearly. You need to understand one more point clearly. Which point? When transistor is on means based upon this base voltage. But here it is not given any feedback to the what now, this operational amplifier. the output may be plus VCC or minus VCC only possible. But here when you are getting the base voltage of the transistor plus VCC, I mean positive value, then transistor is on. If you are getting this output voltage minus VCC, the transistor will not conduct. It comes to the off state only now. Cut-off state only possible. Once the transistor is on because of the base voltage of VCC, collector current is going to flow in the transistor. If the collector current passes through the transistor, LED glows. LED glows. If this base voltage becomes a negative voltage, transistor is off, no doubt. If it is off, no IC, LED will not glow. This point is very important. So when I will get this voltage plus VCC, when possible? When V plus is greater than V minus value, catch my point. If V plus is greater than V minus value, this is a V minus, this is a V plus. V plus is greater than V minus, the output voltage of the op amp is plus VCC, we know very well. So initially we should understand what is this base voltage. V negative voltage I want now. This negative potential how much here now. If this, but based upon that potential only, I can write the condition. Vi must be greater than that potential. Then only here I will get plus Vc. This voltage I want to give you a name of V. This potential I want to give you a name of V. This is Vi. The V is, but because of the connection of the supply, current is going to flow. It doesn't divert this side. It's not diverting to the negative terminal. Why it doesn't divert? You know very well. The op amp can have input impedance of infinity. At the time, it doesn't allow any current. So total current is passing through this path only now. So by means of applying voltage division formula, I can find V value. What is voltage division formula? V equal to, I can write clearly. V equal to, I can write supply voltage into 10 volts into 10 volts into 2K by 8 plus 2, 10K. I can write now 10K. I can KK cancel, 10 cancel. I am getting 2 voltage here now. I am getting 2 voltage. I am getting 2 voltage. Are you getting the same value? We are getting voltage of 2 voltage only. After getting 2 voltage, you can write the condition here now. If Vi is greater than 2 voltage, I will get output of the op amp is a plus VCC only. Catching my point now? If, I can write clearly here now, if Vi is greater than what value? 2 voltage, I will get this voltage is nothing but a plus VCC. Plus VCC means 10 voltage I can get directly here now. There I can get 10 voltage clearly now. Catching my point now. V plus I can write if Vi is greater than 2 voltage. This voltage is nothing but a 10 voltage possible. This voltage is nothing but this voltage is a 10 voltage only possible. What voltage? Output of op amp. Op amp is 10 voltage you can get now. If I am getting the base voltage of 10 voltage, what is going to happen? Now transistor is on. Now the transistor is on. If the transistor is on, collector current is going to flow in the circuit. Collector current is going to flow in the circuit. Then LED glows. What is the meaning of this? If Vi is a greater than 2 volts, if Vi is greater than 2 voltage, this portion is a greater than 2 voltage. Greater than 2 voltage means collector current is going to flow, LED glows one time, it glows. From here to here, one time it glows only, I can say. Less than 2 voltage, what is going to happen? VCC becomes, this output of the op amp becomes a minus VCC only now. Minus VCC means transistor is off again. But again, whenever the waveform reaches to this point, from this point to this point, again, output of the transistor is output of the op amp is plus VCC. Then again, what happens now? Collector current is going to flow, LED glows. Finally, from this point to this point, it glows. One more time, it glows. Totally one time only here now. Less than 2 voltage, it is off again. Again, in this particular portion, this is on. Greater than 2 voltage, again VCC equal to 10 voltage here now, same voltage, and LED glows, and third time it will glow only. One more time it is glowing. The totally how many times? 1 plus 1 plus 1. That means in between these two portions, one time it glows. In between these 2 points, one time it glows. In between these 2 points, it glows one time. Totally 3 times possible now. There's a number of times LED glows. Number of times LED glows is, we can write directly. Number of times LED glows is how many times? 3 times only possible. Is 3 times only now. 3 times I can write now. 3 times it glows only, we can say. That is the solution for this question. I hope you followed. We can write here now. This 3 is the option. 3 is the right answer. 3 is the right answer. This is the solution for this question. I hope you followed. Now, I want to give one more question. You try to pay attention to give answer. Okay, I will give one more question. I hope you followed. If any student having any doubt, they can arise. They can message here now. I can understand. Shall I go to the next question? The next question here is, this is the next problem. But I will say this is not going to take a more time. It doesn't take more time. Just I will give 1 minute. Please try to tackle. Please try to give your answer. Yes, time up. How to tackle this question? Nobody responded for this. I will do now. It's a very simple question. What way we can do this problem? What is given problem first of all? Assuming that the op amp in the circuit shown below is ideal. Operational amplifier is ideal, clearly given. The output voltage V0 in volts is dash, is asking to find the V0 value. How to get this V0? How to get this V0? If a problem is given, you need to check the given op amp is ideal or not ideal. If it is a non-ideal, the process will be different. Ideal, the process will be different here now. Ideal or non-ideal means it is given clearly it is ideal. It's given ideal only now. And V plus is given with 1 voltage. V plus is given 1 voltage. Anybody can give what is the value of V minus here? V plus is given with 1 voltage. What will be the value of V minus? That's my question. What will be the value of V minus? I'm asking here now. What is V minus value? but here I cannot say V plus equal to V minus, not accepted. V plus is not equal to V minus in this particular problem. Why this V plus is not equal to V minus? You please watch in this problem. This V minus is directly connected to the ground. Ground means it is a 0 voltage. Even this node voltage, 0 voltage only possible. In between these 2 points, we don't have any resistance, no resistor. The potential here and here remains same only now, no variation. So if I have here the 0 voltage, even this node voltage is also same 0 voltage I can find. Same 0 voltage. Can you find any current across this 1 kilo ohm resistor here now? We cannot find any current. The reason is this is a 0 potential, this is a 0 potential. Difference of the potential is a 0 only now. Current is 0. The potential difference between the 2 points is same here now. Then current through the watt-hour resistor will be 0 only possible. You know very well. Then here, how we can find the V naught here now? How we can find the V naught means we should apply the condition only here now. V plus is greater than V minus here now. I can say condition, you know, if V plus is greater than V minus here, V plus is greater than 1, 1 is greater than 0. In that case, V naught equal to, I will get V naught equal to plus V sat I can get now. Plus V sat is possible. If V plus is greater than V minus, V naught is a plus V sat. If V minus is greater than V plus, V minus is greater than V plus, I will get the minus V sat, minus 12 voltage possible. V plus and V minus are equal means, you know, every one of the problem we did, we are doing the problems. V plus and V minus are equal means how to find. We are applying the KVL and we are getting the solution for that question only now. Anyhow, here the V naught equal to V sat means what is the V sat value here now? V sat is nothing but the 12 voltage only now. V naught equal to V sat, that V sat is nothing but the 12 voltage. That means here this is connected with this. This is called as a V sat value. This is called as a minus V sat. Plus VCC equal to 12 voltage minus VCC minus 12 voltage. VCC can also be called as a V sat. This is a minus V sat. That means output voltage always remains in between minus 12 to plus 12 voltage only now. So finally plus V sat, 12 voltage possible. The solution for this question is a 12 voltage only now. I hope you followed. But I want to give you one more question. But you please try to do this problem without my help. I want to give one more problem. This is the next problem. But I will give 2 minutes. You please try to tackle this question without my help. Good question. Please try this question. this time up here. How do you get answer for this question? But you check what is given in this question. In the circuit shown, the op-amp has finite input impedance. Input impedance is infinity. Catch my point. Infinite voltage gains. Voltage gain is infinity and zero input offset voltage. The output Vout is asking to find output voltage Vout. Vout is required. Certain conditions are given: finite input impedance, infinite voltage gain, and zero input offset voltage given. We should understand somewhat about these points. First of all, you can say the given op-amp is ideal or non-ideal here. The given operational amplifier is ideal or non-ideal. But ideal case, everybody knows the input impedance is infinite, but here it is given a finite input impedance. Finite input impedance you got means you cannot say directly the given operational amplifier is non-ideal. You cannot say directly. Still you need to watch. The op-amp has the op-amp gives voltage gain of infinity. Voltage gain it is giving infinite means 100% one infinite value we have in the voltage gain. Then we can say it is a ideal ideal operational amplifier. Infinite value of voltage gain. Whenever it is existing, you can say it is a ideal operational amplifier and also ideal operational amplifier only now. And a zero input offset voltage, that means the difference of this voltage must be zero voltage. Input offset voltage means the difference of this voltage must be zero voltage only. But the output voltage Vout equal to how much is asking in the problem. We know very well. Input offset voltage 0 means this is 0 voltage. Anyhow, this V plus is a 0 only here now. Here given V plus is nothing but the 0 voltage this now. This also with 0 voltage only. This also with 0 voltage only. Understand my point now. And here one more point you need to understand here now clearly. But here the input impedance is not infinity. It is a finite value given, finite input impedance. At the time it is going to flow some current in this particular path only now. I2 equal to minus I1. I2 equal to say minus 1 will flow this side. But why this current is passing this side means because of the finite input impedance. Infinite input impedance is given means no current will flow. Now, by using this condition, we need to find Vout. How to find? Just by applying the nodal analysis, we can get the Vout only here. By using the nodal analysis means this current, I say I want to apply a nodal analysis. According to nodal analysis, this current plus away from the nodes, this current plus this current equal to 0. We should consider this current also because the finite input impedance is there now. So, some current will divert that side only now. But apply nodal here. If I apply the nodal analysis, this current is 0 anyhow. 0 minus 0 by R1, 0 value, this value. This current is 0. Plus this current you know very well, 0 minus Vout by R2. Difference of voltage by resistance. That means current across this R2. 0 minus Vout. 0 minus Vout divide by how much? R2 I can put here now. This current. And one more current is passing because the finite input impedance, some current is passing. Directly I can write that current equal to I1 plus I1 plus I1. Summation of all the currents equal to 0. You know very well. Now, my aim is to find Vout here now. Minus Vout by R2 equal to I1 I can get here now. Equal to I1 I can get. Minus I1. This side when it comes minus I1. So, Vout equal to what I will get here now? Vout is nothing but I1 into R2 I can get. I1 into R2. This is one of the gate problem. Vout is nothing but I1 into R2, I1 into R2. Which option is correct here now? Option C is correct in this particular problem. Option C, I1 into R2. This option is correct in this particular problem. I hope you followed. It's a very simple question. But I wish to give one more question in your hand. Please try to do this. Follow this. The students are not messaging their solution, their answer. Initially, the students must try to give the answer. Whether you are practicing or not, that I can understand only from your answers only now. Okay, I want to give one more question now. Please note down this. This is one more question. You please try to do this question. I want to give 2 minutes for this question. Yes, time up. This is one more question. Here required, what he is asking in the question, we can see. For the op-amp circuit shown in the figure, V0 is. For the op-amp circuit shown in the figure, V0 is. But this the problem it is given op-amp is ideally specified. Is in the bracket op-amp is ideal one. That's given. For the op-amp circuit shown in the figure, V0 is dash. V0 is, which option is correct, he is asking here now. How we can do this problem? Anyhow, op-amp is here ideal, given, that is my mistake, here not given. Op-amp is ideal one. Is asking to find V0. This circuit I can redraw in different way. Directly you can get, just for your understanding purpose, in steps I will write, then students can understand easily now. Every student must understand, that is my aim. Understand now. This circuit I can draw like this, first of all. There is an op-amp, minus and plus. This is V0. This negative terminal is connected to the 1 kilo ohm resistor, 1K. The supply voltage is common for this 1K and this 1K. For both sides it is common. I can put this a 1 voltage. I will separate this. here connected with 2 kilo ohm resistor. This is 2K resistor here given. And positive terminal is connected to 1K this side. This is 1K resistor. This is connected to 1 kilo ohm again. Same 1 voltage for both. It's just a separated. Unnecessary directly also you can get. Understanding purpose I am giving now. But this node voltage I wish to take it as a Vx for example. Any name Vx or VR, V1 or V2 or any name, otherwise V plus. Anyhow, this node voltage and this node voltage same. V plus and V minus are same Vx I will get. If I know this Vx, I can find directly V naught directly. The Vx is nothing but voltage across 1K. Can you find any current across this side? No current. Ideal op amp, it doesn't flow any current. Not given means input impedance is infinite only now, not given here now. So, Vx is nothing but voltage across 1K. According to voltage division formula, 1 into 1K by 1K plus 1K, 2K, I can write K can cancel 0.5 voltage I am getting. I am getting 0.5 voltage here now. This voltage is a 0.5 voltage. Even this voltage also same 0.5. Now I can apply KVL, nodal analysis I will apply to find V naught. This current plus nodal I want to apply. This current equal to 0. It doesn't flow any current this side. So I can write 0.5 minus 1, 0.5 minus 1 divided by 1K plus this current 0.5 minus V naught, 0.5 V naught divided by 2K I can get here now, equal to 0. Summation of all the currents equal to 0. Here I can cancel KK. But I can expand here now 0.5 minus 1 minus 0.5. Take LCM minus 0.5 into 2 minus 1 I will get plus 0.5 V naught that equal to 0 after LCM. Finally, 0.5 V naught equal to what I can get? V naught equal to I can get minus 0.5 voltage only now. Minus 0.5 voltage I am getting now. This is the output voltage. Please note of this. That is the solution. I hope you followed. But I want to give one more question in your hand. You must try this now. You must try without my help. I will give you. The next problem is, this is the next question. You take 2 minutes to give answer. Yes, time up. Yes, how to tackle this question? But you check what is given here, how the question was asked here now. From that you can understand clearly. Assuming that the op amp in the circuit shown is ideal, V naught is given by. Mostly in the gate papers you can find V naught only now. Output voltage only, maximum asking in the gate paper. Most of the questions. Assuming that the op amp in the circuit shown ideal, V naught is given by, is asking to find this V naught value. It is also a gate question. How to get this V naught? To find the V naught, I say, what is this node voltage here now? This voltage is equal to how much? Anybody? Anybody can say? This positive terminal is connected with V2. Negative terminal this side is a V1 is given. V plus and V minus are same. For ideal op amp you know very well. So this voltage is nothing but the same V2 I can write. Same V2 I can get now. Now I can apply nodal analysis to find out the V naught value. Nodal here how to apply? Away from the node you take the current directions. Conventional directions you know. Away from the node, this current plus, this current plus, this current equal to 0. You will not find any current this side. For ideal op amp, input impedance is infinity, current passing to the negative terminal is 0. Everybody knows very well. Now how to apply the nodal analysis here now? You please watch, I will apply the nodal. I say here V2 minus V1 by R, this current, V2 minus V1, V2 minus V1 by V2 minus V1 by R here, plus V2 minus V1 by R. What about this current? V2 by 2R, V2 by 2R I can write. V2 by 2R, that current. What about the current through 3R? Current through the 3R means difference of this voltage by resistor. Difference of voltage V2 minus V naught, V2 minus V naught, V2 minus V naught divided by 3R. This is equal to how much? 0 I can take here now. That equal to 0. I can cancel R term here totally. LCM is 6 V2 here, minus 6 V1 here, 6 V2 minus 6 V1, here 3 V2 here, 3 V2 plus 2 V2 here, minus 2 V naught. This is equal to 0. LCM I have taken here now. By using, take LCM and find it. Vijay Vardhan. D you say, okay, you can check now. The answer is D. I'll check now. I'll check now. There is a option is D is a correct now. Exactly correct now. Option D is correct. Vijay Vardhan, you are correct. 100% perfect now. What you gave is right. And here this is equal to 0 I am getting here now. Here I will get here now minus 6 V1 here, and any V2, 2 V2, 5 V2, 11 V2 I will get here, 11 V2, that equal to 2 V naught. My aim is to find the V naught value. V naught equal to minus 6 by 2 minus 3 V1 plus 11 by 2 V2. Finally, this is the solution. This is solution. Which option is correct? Option D, minus 3 V1 plus 11 by 2 V2. Exactly correct. Option D is right in this problem. We can say option D is correct in this particular problem. This is also a gate question only. I hope you followed. And I want to give one more question. You please try from the operational amplifier. I will give one more question. The next question. Please try this question without my help. I will give you time of 2 minutes. Yes, time up. Any student? Vijay Vardhan, any chance to give answer? Are you getting any answer for this question? It is also a very simple question, but asked in the gates. But what is given in the problem? You please try to understand. In the circuit shown below, the op-amps are ideal. Op-amps are ideal here now. The given op-amps are ideal. Then V out in volts is asking to find the output voltage. How to get this output voltage? You know very well. V plus and V minus are same for ideal op-amp. May know what is this V plus here? What is V plus? I am asking question. What V plus is possible? Anybody? What V plus is possible in this particular problem? You need to understand one point here. The supply, here the voltage source is connected here, 1 voltage. For ideal op-amp, input impedance is infinity. If input impedance is infinity, current passing through this wire is a 0 amperes only. Input impedance is infinite means this current must be 0 amperes only possible. No current will flow towards V plus. The reason is input impedance is very high. Then drop across 1 kilo ohm is 0 voltage only. We cannot find any voltage drop here now. If here given 1 voltage, same 1 voltage you will get here. Same 1 voltage. V plus is a 1 voltage only. And V plus equal to V minus, this also with 1 voltage. I wish to find initially this Vx. Output of first op-amp, I want to denote by the symbol Vx. Vx I want to denote this voltage. But again, you know, if it is Vx, even this voltage is also same Vx. Because V plus and V minus are same only now. Anyhow, without knowing Vx value, I cannot find V out. How to get Vx here? You please watch. How to get Vx? I want to find Vx here now. To find the Vx, I wish to apply the nodal analysis here now. Only nodal is the powerful tool in operational amplifier. Away from the node, this current plus this current equal to 0. This side no current, you know very well. I can find now. And this current is 1 minus of minus 1 plus 2. Minus of minus 1 plus 2 by 1k here. Plus this current is nothing but 1 minus Vx. 1 minus Vx divide by 1k. This is equal to 0. I can cancel 1k, 1k. And I will get 1 plus 2, 3 plus 1 minus Vx equal to 0. Finally, Vx equal to, I am getting 4 voltage here now. Vx is 4 voltage. But here you please watch once here. I am getting Vx value. This voltage is nothing but the V out. When this voltage is V out, current is going to flow this side. Current will go this side. Current will go this side. And no current is going to flow in this direction. This side no current. Input impedance is infinite. The total current will be dividing this side only. So this is what the same current is passing in this branch. I can say voltage division formula is applicable here now. If the same current is passing in the network, you can apply the voltage division formula to find the V out. According to voltage division formula, Vx equal to, you know very well, supply voltage V out into 1k by 1k plus 1k, 2k I can get. Just I applied voltage division formula. Then I can find Vx value, we know 4 volts. This is V out by 2. Kk cancel. Finally, V out equal to how much? 4 into 2, 8 voltage we are getting. The output voltage is nothing but the 8 voltage here now. Every student should understand. That's why I'm going very slow. V out is 8 voltage. So which option is correct here? Option C is correct. Option C is correct in this particular problem. 8 is right. That is the solution for this question. Please note down this. That is the solution. And I want to give one more question. You please try by using op amp. By using op amp, I want to give one more question. Yes, this is one more good question. You please try to tackle. I am giving 2 minutes for this question again. Yes, time up. Getting anybody solution for this question? Now, how to get answer for this question? I do now. Please watch. But what is asking now? Find the output voltage V naught in the following circuit. Figure given here now. Assuming that op amps are ideal. All the 2 op amps are given. Those 2 op amps are given ideal only now. We need to find the output voltage. How to get this output voltage? Nodal is a powerful tool, I said already. By using that nodal, we can find easily now. How I will do, please watch. This voltage is nothing but the VA. This potential, because it's a 1 voltage you got. Same 1 voltage means V plus and V minus same. This is also 1 voltage. VA is nothing but 1 voltage. If it is 1 voltage, same node, this point and this point you can combine. Same 1 voltage. We can combine and we can make it as a single point only. We can make it as a single point. And this node voltage, I want to take it as a VB, potential at B point. VB I want to take. This potential I want to denote by symbol VB. Here the V plus is 2 voltage, V minus must be 2 voltage here, you know very well. If it is 2 voltage, same 2 voltage existing here now. We don't have any resistor in the middle, so same 2 voltage will be maintained here now. Now we need to find V naught. Directly V naught I cannot get. I must find at first this VB. VB required, because is it passing any current through this path or not, we can know only by finding VB value. If this VB is the same 2 voltage, if you are getting, no current will flow. Other than 2 voltage if you got, it will flow some current this side also. That current will be useful to find out the output voltage. Here I want to apply the nodal analysis, this current plus, this current plus, this node and this node same, this current, this node same, this current equal to 0, 1. This side no current. Apply nodal to get answer. If I apply the nodal analysis, I will get like this. This current is 1 minus 0 by 2k. 1 minus 0 by 2k I can write. This is 1 minus 0 by 2k. This current is 1 minus VB by 2k. 1 minus VB by 2k I can write. 1 minus VB by 2k. What about this current? 1 minus 2 divided by 1k I can write. This is equal to 0. Summation of all the current 0. Once again repeating. This current 1 minus 0 by 2k. This current 1 minus VB by 2k. This current 1 minus 2 by 1k. These are the 3 currents passing here now. Now VB required 1 by 2k, k cancel, 2 is LCM. 1 plus 1 minus VB, here 2 multiply 1 minus 2 minus 1 into 2 minus 2 equal to 0 I can get here now. 2 minus 2 0, finally VB value is nothing but 0 volts. I am getting VB equal to 0 here now. I will write here now. I say this VB is nothing but 0 voltage. If VB equal to 0 voltage, is it passing any current across 2 kilo ohm or not? Yes, it passes. Current passes from higher potential to lower potential, no doubts. Anyhow, by using this, by applying the nodal analysis here now, I got VB value. To find the V naught, I selected this node. Away from the node, I can select the current directions. This current plus this current. You should not stop with these two currents. This current also, because this node and this node same. Plus this current away from the node. This current equal to 0. This current, that current, and this current is equal to 0 only. But I wish to find this current at first. Any current you get in 2 minus 0 by 2k. 2 minus 0 by 2k here. By 2k I can put. Plus this current 2 minus 1 by 1k. 2 minus 1 by 1k I can write. One more current. Plus 2 minus 1 by 1k. And this current is nothing but 2 minus V naught by 2k. 2 minus V naught by 2k. Summation of all the currents equal to 0. You know very well. Again repeating. 2 minus 0 by 2k. 2 minus 1 by 1k. 2 minus V naught by 2k equal to 0. K will be cancelled. 2 is LCM. 2 minus 0, 2 itself. 2 minus 1, 1, 1 into 2, 2 I will get here. Is a 2 minus V naught. This is equal to 0. But I want V naught value. 6 volts here possible. V naught is nothing but 6 volts. That is the solution for this question. I hope you followed. Note down this. But I want to give one more question here now. In your hand, I will give now. Yes, you please try this question now. Next problem is this. By using the op amp, I am giving one more. Just 2 minutes I am giving now. Please give answer. Please try it. Yes, time up. Getting anybody? But I want solution for this. V naught is required for this given problem. What is given here? For the ideal op amp circuit of figure shown, determine output only now, PUT put. I want output voltage. Output voltage required. This is not required. Output voltage only. You can remove this now. Output voltage required. OUT, output voltage. V naught required. How to get output voltage? V naught. I want V naught here now. How to get V naught? But in this circuit, V plus and V minus are same. V plus and V minus same, because it is a ideal op amp only. I wish to select this voltage as Vx, V minus. Even this node voltage also same Vx. It won't be changed. Same Vx only possible. What about this node voltage? Anybody can give answer? What is this node voltage? I am asking. What is this node voltage? This node voltage is same 4 voltage. This 4 voltage will be same. This is same 4 voltage. And this point is connected here, means it may be connected to the ground only now. 0 voltage only. One must be ground. This is 0 voltage. This is a V naught. Understand now? Without Vx, I can't get V naught. Again, same point. Nodal is applicable. Nodal is a powerful tool. I am informing you. But from this node, current directions you must take away from this node. This current plus this current equal to 0. It doesn't flow any current this side because input impedance is infinity. How to get Vx? How to get Vx? According to nodal, Vx current across this 100 ohm, Vx minus 4 by 100. Vx minus 4 divided by Vx minus 4 by 100 here, plus Vx minus this 100 ohms connected to the ground, 0 only here now, 0 potential. One is the reference voltage, 0 only now. Vx minus 0, Vx by 100 is possible. Vx minus 0 by 100 only. This is equal to 0 because only in two directions current is passing here now. So 100 cancel, Vx minus 4 plus Vx equal to 0. 2Vx equal to 4. And Vx is nothing but the 2 voltage we are getting. Yes, we got Vx 2 voltage. Please note down this. We got Vx 2 voltage. So if it is a Vx is a 2 voltage, even this voltage also same 2 voltage now. We are getting 2 voltage here now. We are getting 2 voltage. To get the output voltage, I want to apply the nodal again. Away from this node, I want to take this current plus this current equal to 0. Away from the node. This side no current. Input impedance is infinite. No current will flow. Apply nodal again. I want to apply nodal again. This current is 2 minus 4. 2 minus 4 divided by 2 minus 4 divided by 100 plus this current is this current, if you want to find this voltage, what now? V0 only here now. You know very well. You know very well. If it is a 0 voltage, this must be V0. If it is V0, this voltage also same V0. Same V0. Now I want to get what is this current? 2 minus V0. 2 minus V0 divided by 99. Divided by 99. That equal to 0. I say 2 minus 4 by 100. 2 minus V0 by 99. 2 minus 2, 2 minus 4 minus 2 by 100 here, plus 2 minus V0 by 99, that equal to 0. Use calculator, you will get V0 value. The value of V0 will be 0.02 volts possible, 0.02 volts. That much voltage is possible. V0 is 0.02 voltage. Please note down this. Please note down these questions. So by using the op amp, these are the 10 questions I selected here now. By using the MOSFET, I will do few more questions now. You will get some idea, some practice you can have here now. Yes, I will give now. Next question I will give by using op amp. Sorry, by using the MOSFET I will give. This is the first question. But I want to give you time 2 minutes here. Yes, time up. Yes, in the gate paper, MOSFET is given much importance. Operational amplifiers are given much importance. You should not leave these two topics. Every student should prepare these two topics perfectly. They can expect questions. Understand now. You try to do more number of problems from the operational amplifier and MOSFET. Even the analog and even EDC also, I will discuss in the EDC, no problem. The analog MOSFET is more important, and also operational amplifier very important now. Understand? Yes, what is asking in the problem? Please check it here now. Consider the circuit shown with an ideal long channel N MOSFET, enhancement mode, substrate is connected to the source. It is nothing but the enhancement mode N channel MOSFET is given here now. Enhancement mode N channel MOSFET. The transistor is appropriately biased in the saturation region. It is in saturation region, he says, with VGG and VDD such that it acts as a linear amplifier. VA is the small signal AC input voltage. Input VA is nothing but the small signal voltage only. At the nodes A and B respect voltage. Anyhow, is asking the value of VA by VB how much? Voltage at the point of A divided by voltage at the point of B. That ratio required from this problem. VI is the small signal, gain only now. VA is the small signal input voltage. VA and VB represent the small signal voltages only. VA by VB required. VA and VB are DC or AC means the problem clearly given. Small VA and VB, A and B. Small signal voltages at the nodes A and B respectively. A and B small signal voltages only. The value of VA by VB. Understand? Required here now. How we can get that value? Please watch. To get this value, AC analysis I want to apply, because AC voltage of VA and AC voltage of VB required here now. Under AC analysis, I can write. Under AC analysis, I will get this value. It doesn't take more time to complete this question. Under AC analysis, the condition is there now. Wherever the DC source is given, you must short circuit. DC voltage source must be shorted. DC voltage sources are short circuited. You must short circuit. If there is any capacitor, under AC analysis, you must short only now. Short. DC voltage shorted. If there is a capacitor, you must short under DC analysis only. But AC source is to be taken as it is here now. I say there is a MOSFET here. That MOSFET I will draw as it is. N channel MOSFET. This is connected with AC source. That source is given as VI. DC source must be shorted, I said now. You must short this. The 4 kilo ohm here connected, this is the DC source, that also we need to short. I can connect here 4 kilo ohm resistor this side. 4K. DC source I shorted, I connected to the ground. This node voltage I want to take it as a VA. This node voltage is VA. And here the B is connected to, this is connected to the 2 kilo ohm and connected to the ground. B point this is a VB, potential here is a VB. You are asking VA by VB. Under AC analysis, the current which is passing through this side is ID, small ID. Drain current is going to flow this side. If the gate current is approximately 0, input impedance of the NMOS is very high. the time this current is approximately 0. If it is ID, even this current also must be taken as a ID only. Same ID is allowed. Same ID required. Just by applying the KVL, I can get VA here now. Just apply KVL this side. But this potential is a 0, no doubt, grounded here now. 0 voltage equal to, I can write, when I go this side, some drop 4K into ID. 4K into ID plus VA. So, VA equal to, here I can write minus 4K into ID. 4K into ID, I can write VA equal to minus 4K into ID is allowed. To find out the VB, I want to apply KVL in this part. Just a KVL I apply. VB equal to, I can write VB equal to 2K into ID here now. 2K into ID I am getting now. This is the value of VB. Now, the ratio required, what ratio is asking to find here now? Is asking to find the ratio VA by VB. Thereby required VA by VB. This ratio required. VA we know minus 4K into ID and VB is nothing but 2K into ID. ID cancel, K cancel, minus 2 possible. VA minus VB is a 2, minus 2 only possible. This is the solution for this question. Please note down this. Please note down this. Answer is minus 2. I hope you followed. Please note down this. And I want to give one more good question in your hand. It is based on the analysis only comes. I'll give you 3 minutes. Please try this question. I'll see how many students will do. This is the next question. But I want to give you 3 minutes for this question. Yes, time up. Yes, here solution required for this question. A very good question. It's really a good question. What is asking in the problem? Please check it. Then you will get the idea. In the circuit shown below, assume that the long channel NMOS transistor is biased in saturation. That means the NMOS is biased in saturation is given in the problem clearly. It is in saturation. The small transconductance of the transistor is GM. The transconductance of this MOSFET is given GM only here now. Neglect body effect, channel and modulation, and intrinsic device capacitances. All these are neglected. The small signal input impedance Zin in terms of in J omega required is dash. Zin means when the view is made this side, what Zin J omega is possible. You need to find that now. How we can find this? How to find this? That is more important. But I want to draw this circuit, small signal equivalent circuit I want to draw for the given MOSFET. From that one we can find the what now Zin. Zin in terms of S domain I will get at first. Wherever S is given, there you can put J omega directly. How we can draw? Please watch it. I will do. But in the problem, this is what now input impedance equal to input voltage by input current only. Input voltage by input current. I will connect a voltage source. One test source V I want to connect here now. I connected one voltage source. That voltage I have taken V. Test voltage source. Because of this V, it is going to flow current I. AC equivalent circuit I am drawing here now. Here there is a C1. C1 is connected here. This is a C1. I can connect one branch only. Just directly I have taken this side. One capacitor. Even here are this side same only now. 1 by C1S. 1 by C1S. In S domain. In S domain means it will be in ohms only. And this side I say from gate to the source, gate to source must be open circuited, you know, because input impedance of this MOSFET is infinite, very high value, you know. At the time current through this gate is a 0. 0 means gate and source must be open circuited. This is gate, this is the source, this point, and this point and this point. 2 points I have taken out. This is a gate and source. This voltage I want to take it as a VGS I will put best. Small v, small VGS they will put there only. Small v or this v. VGS I want to take now. This voltage. Because the MOSFET equivalent symbol, you know, open circuit and must connect with a drain current is going to flow. This side current is required. This is the equivalent circuit of the what now? MOSFET. AC analysis, you know very well. Here required current source. This current is to be taken as a GM into VGS, no doubt. GM into this current depends upon this voltage. This current depends upon this voltage. VGS. What you have to multiply to get the current? GM you have to multiply. Anyhow, this circuit is nothing but AC equivalent circuit of MOSFET I say. Catching my point now. And this drain is connected to the ground. This is connected to the ground. If you got out, you can say directly one MOSFET is equal to, I say I can write clearly now, understanding purpose. The MOSFET is given here. This MOSFET equivalent circuit I can draw directly here now. One open circuit this side is nothing but the current. This voltage is nothing but the VGS, GM into VGS. the equivalent circuit for the MOSFET in AC analysis. That only I have done GM, VGS, this taken. But here the CL is connected this side. Here I can connect CL. One capacitor I connected here now. But I want to get this value in S domain. 1 by CLS I can write. 1 by CLS in S domain because it is in ohms then. My aim is to find the what now. When the view is made this side, Zin required. Zin means V by I. That ratio required. You know very well. I am going very slow because every student must understand. That is my interest. This current is, I mean this side no current. Same I will flow this side. And this side also, this current is, this side I, this is a GM VGS. I plus GM VGS. That much current is passing. I plus GM VGS, it flows. But we know very well, Zin is nothing but V by I. V by I. Everybody knows. That ratio I want to get now. How we can find this? V means even this node voltage also same V. So I will apply the nodal analysis. Just a nodal. That is just a KVL I will apply here now. Just apply the KVL to get that ratio. Apply KVL here. If I apply the KVL here, V equal to I can write current into what value possible now? XC what now? Current into what now? 1 by C1S. You please note on this. This by this. Volts current into what now? This by what now? It comes now. What is the voltage drop across the capacitor? You find it now. Voltage across the capacitor means I by what is possible. Here one more point you have to understand now. This is VGS is nothing but voltage across this only. VGS equal to same voltage drop only now. Voltage across this. VGS is nothing but, I can say VGS is nothing but parallel. Same. I by C1S I can write. Current into capacitor reactance. Current into capacitor reactance I am getting here now. Current into 1 by C1S. But this side current voltage equal to this current, this voltage drop how much? I by C1S. I by C1S. When I go this side, some drop, current by voltage I want a current into this capacitor reactance. Current means I plus GM VGS, current into capacitor reactance. Capacitor reactance means 1 by CLS I am getting now. 1 by CLS I am getting here. Yes, I got this now. You know very well VGS is nothing but I by C1S. I want to substitute here now. V equal to I can write I by C1S plus you split I by CLS plus GM into VGS. VGS is nothing but I by C1S. I by C1CL, S into S, S square I can get now. C1CL, S square I will get now. Now I can take I in common. V by I will get directly. I say V by L is nothing but V by L I want. V by I. How much value possible? Sorry, V equal to I want not. Sorry, what is given here now? This is the V by I. V by I want. V by I. What is V by I? 1 by C1S. 1 by C1S plus one more value. 1 by CLS. 1 by CLS. And one more is there now. 1 by CLS. Still what is left? 1 by CLS. GM by C1CL. GM by C1CL. GM by C1CL. S square I am getting now. By S square I am getting. But I am getting this V by I. V by I is nothing but this Z, you know. But I want Zi, Z in I want in S domain I got, Z in J omega I want here now. Z in J omega I want. How do you get this? Please wait. I want to get, just wait. But I want to get Z in, sorry. Z in I want, yes. I want Z in J omega. In J omega I want to get. Wherever S is given, you put J omega. S means J omega. Wherever S is given, you put J omega, CL omega. Wherever S is given, J omega. S equal to J square is -1 minus GM by C1 CL omega square I can get. Finally, this is going to be the solution for this question. It is also GATE question. GATE 2024 ECE paper asked this question. But which option is correct here now? You please watch. Which option is correct here now? Please check it exactly. Which option is right? Which option is correct here now? Option B is correct, I think. Check it. Option B, GM C1 CL. Which option is correct here now? Option A or B or C, or you check it again. 1 by J C1 omega. 1 by J omega C1. 1 by J omega CL minus GM by, sorry, A only correct I think now. Option A or B, check it here now. Which option is correct now? Mostly it comes option C, I think. C1 C2 omega square into minus GM 1 by J omega C1 1 by J CL. That answer is possible. Option A correct, I hope it now. Understand? Anyhow, this is the final solution for this question. I hope you followed. It's a very good question really. And I wish to give one more question in your hand. You please try to tackle this question without my help. I want to give in your hand one more question. This is the next question. Please try this. I will give you time of 3 minutes for this question. You take 3 minutes and give answer.
got these many.
Yes, time up. Getting anybody's solution for this question? Any student can give answer. But what is asking in the problem, you please watch. For the circuit shown, assume that the NMOS transistor is in saturation. Its threshold voltage VTN equal to 1 volt and its transconductance parameter mu n COX W by L equal to 1 milliampere per square volts. Neglect channel length modulation and body bias effects. Under these conditions, the drain current ID in milliamperes is asking to find the drain current. This is the MOSFET only now. This is a drain current means the arrow must be here only. Understand? But the values are given. How we can find drain current in this network? What is the biasing? What biasing is made for this NMOS means you can say voltage divider biasing is made. For this biasing circuit, we need to find out the current ID. We should assume the transistor is in, this MOSFET is in saturation. Yes, directly given, I think, no. It is in saturation only. It is in saturation only, given clearly. Now, initially, to find the ID, I wish to find what is the gate potential I want to find. This potential I want to find, VG value. This gate potential is required. Supply voltage is nothing but 8 voltage. R1 current will flow this side and will flow this side and will flow this side only. This side no current. Reason is input impedance of MOSFET is very high, approximately infinity only. By using the voltage divider formula, I can find VG here now. I wish to find VG by applying the voltage division formula. VDD into R2 by R1 plus R2. VDD into voltage division formula into R2 by, I can write R1 plus R2 here. Then I can get what is VG here now. What is VG value? VDD is nothing but the 8 volts. R2 is nothing but 5 mega. All are in mega only. 5 plus 3, 8. 8 cancel. I am getting the 5 voltage. I am getting this voltage is nothing but the 5 voltage here now. I say this potential is 5 volts. But this potential is nothing but this voltage is nothing but VGS, gate to source voltage. Everybody knows very well. If gate current is approximately 0, if it is ID, even this current also ID. This problem is given ID value under DC analysis required. All are DC parameters only now. Just I want to apply KVL in this path. I will apply the KVL in this path. VG equal to VGS plus ID into 1K. I want to apply. I say I applied KVL here. If I apply the KVL, VG equal to 5 volts equal to, when I go this side, some voltage drop, VGS plus 1K into 1K into ID. 1K into ID. That's possible. But without ID, but VGS is there, no ID value, we know ID. First VGS you find. Once you are getting the VGS, you can measure the ID value. Without VGS, we can't get it now. But you know very well, when the MOSFET is in saturation, 1K it is now. when the MOSFET is in saturation condition, drain current, you know the formula. What is the drain current formula? Mu n CoX, mu n CoX by 2 into W by L into VGS minus VT whole square, you know very well. When the when the MOSFET is in saturation, the formula you will apply generally. It is in saturation given. VT means threshold voltage, VT and 1 voltage only now. VGS we have to calculate. The 5 voltage equal to VGS plus 1K. Mu n CoX is given, mu n CoX W by L 1 milli. 1 milli is given. Divided by 2 here, VGS here, minus VT, threshold voltage is given 1 whole square. But here it takes time, you know. You must expand this equation. VGS you are going to find here now. But if you try it by using the calculator, you will get VGS. I am giving directly now. VGS you will get 3 voltage you will get here now. You will get 3 voltage if you expanded this. Once you are getting the VGS value, you can find ID. 5 equal to, I will substitute in this equation, 5 equal to VGS, VGS means 3 volts, plus 1K into ID, 1K into ID. But I want to find ID value. ID is nothing but 5 minus 3 by 1K. So finally, ID is nothing but 2 milliamperes possibles. This is the solution for this question. I hope you followed. Please note down this, 2 milliamperes of current is possible. That is possible now. Follow this. If any students are having any doubts, they can ask. They can ask the questions here now. From the MOSFET, these 3 questions I want to give here now. Yesterday I did feedback amplifiers questions only now. But a certain problems asking based upon the analysis base only now. Analysis base. If that analysis, if you know directly, you can give. The many people will memorize the formula, that is unnecessary. Just I will explain 4 basic amplifiers from the feedback amplifiers now, because sometimes asking the gates. I was in many papers. Those questions I want to do. Understand now? Shall I do them now? This you followed, I hope it now. I want to give the next one. Here I want to give the now. From the feedback amplifiers, I want to discuss certain questions here now. It is not a theory question, theoretical questions only. It is a non-numeric only now. Understand my point now? That means basic amplifiers you will ask sometimes in the feedback amplifiers. Repeated question, these are all basic amplifiers. These basic amplifiers I want to give, very, very important. You know very well there are 4 basic amplifiers. One is a voltage amplifier, one is a current amplifier, one is a trans resistance amplifier, next one is a trans conductance amplifier. Based upon these basic amplifiers, asking questions. How the questions are asked, I will give. 4 basic amplifier. One is said to be voltage amplifier. Must know, very important, gate point of view. Voltage amplifier. The second one, I want to take it as a current amplifier. And third one is nothing but the trans resistance amplifier. Trans resistance amplifier. Fourth one is trans conductance amplifier. Trans conductance amplifier. I would like to discuss these 4 amplifiers, very important gate point of view. That's why I'm discussing. Understand now. The first one I will select voltage amplifier. The first one is voltage amplifier. Try to understand this. How questions are asked, I will explain. the how that amplifier will be drawn, because sometimes he is giving in one paper I watched in the ECE paper, but he gave this circuit. The given circuit is option A voltage amplifier, second option current amplifier, third one transconductance amplifier, fourth one transresistance amplifier. So you need to identify that. If you want to identify that, you should understand one point. Voltage amplifier is to be drawn with, any amplifier can have input circuit and output circuit. Input circuit is given Thevenin's equivalent circuit, output circuit is a Thevenin's equivalent circuit. You can say that is a voltage amplifier only. Current amplifier, you think it's so. There they will give input is a what now? Norton's equivalent circuit, output is a Norton's equivalent circuit. You will be given now. Third one is nothing but the transresistance amplifier. If it is taken, input must be Norton's, output must be Thevenin's only. Transconductance amplifier means input must be Thevenin's, output must be Norton's only possibles. By using these conditions, we are going to draw the circuits here now. How voltage amplifier is to be drawn? Input must be Thevenin's, they will draw like this. This voltage source I have taken Vs, the resistance I have taken Rs, the resistance I have taken as a what? Ri. This is taken as a Ri. And this side Thevenin's is required. Thevenin's means voltage source must, resistance is required. This is R0 value, this is RL value. These are all the parameters here now. In the Thevenin's equivalent circuit, voltage is given impedance. Voltage means this voltage required, V0. This is a Vi I have taken here now. This voltage is to be taken as a V0 only. This voltage is to be taken as a V0 only. This voltage depends upon these input circuits. The input circuit is nothing but the Thevenin's. Thevenin's means it depends upon Vi. So it depends upon this voltage Vi. That is to be multiplied by A suffix small v, voltage gain. Internal voltage gain into Vi is nothing but the voltage only. You will give once in the gate paper he asked, this circuit is given circuit is dash, voltage or current or what amplifier, it is a voltage amplifier. Both are Thevenin's equivalent circuits. Both are Thevenin's equivalent circuits. And one more question, first question identification, second one, but in the gate repeated question, in voltage amplifier Ri is greater than Rs, Ri is less than Rs, R0 is greater than RL, R0 is less than RL. 4 options you will get now. By using these options we need to find. But here it is a Thevenin's equivalent circuit means you will give importance to the voltage. You are going to give importance to the voltage only. In Thevenin's equivalent circuit you will give importance to the voltage. Voltage must be more required. The voltage is required more, Ri must be maintained more. Rs must be maintained less. Just a diagram if you plotted, the gate question you can do easily now. So here the voltage required more means Ri must be more, Rs must be less. Now you can write directly Ri is far more greater than Rs value. Ri is far more greater than Rs. Asking this type questions in the gates. What about the R0 value? R0 is greater than RL or less than RL in voltage amplifier. You know very well, this is also Thevenin's equivalent circuit. Voltage must be more required and RL must be more required, R0 must be smaller value required. Then I can write directly R0 is far more less than RL. Far more less than what value? RL only possible. R0 is far more less than RL. These two very important. Asking one more question, this. Given circuit is dash voltage amplifier. One more question. Sometimes Ri is a greater than RL, less than Rs. R0 is a greater than RR, less than. Second question in the gate. In one of the paper I was, In voltage amplifier, V naught by Vi equal to how much you will ask? V naught by Vi equal to how much? This voltage by this voltage. Otherwise, you may ask find A suffix small v. You may ask any question. But suppose you are asked to find out the AV in the problem. How you will find? AV means this is the Thevenin's equivalent circuit. I want to find what is V naught from the given circuit. Voltage into AV into VI into voltage division formula I want to apply into RL by R naught plus RL I can write. R naught plus RL I can write. And V naught by Vi. Suppose you are asked V naught by Vi in the problem. Non-numeric questions you will find sometimes. V naught by Vi is nothing but AV into RL by R naught plus RL. So if you are asked to find out the V naught by Vi, this is the value. And also you can give V naught by Vi. V naught by Vi can also be given as a suffix capital V. Suppose you are asked to find what is A suffix small v. What is A suffix small v finally? You are asked to find out the A suffix small v. If RL is divided, 1 plus R naught by RL. 1 plus R naught by RL into A suffix capital V. This is the A suffix small v formula. You may ask V naught by Vi. V naught by Vi means this value. Suppose you are asked to find the A suffix small v, this value positive. Sir, what is A suffix small v? What is A suffix capital V? A suffix small v is called as a internal voltage gain. Internal voltage gain. Internal voltage gain. I am going very slow because every student must understand. Or we can call one more because internal it is existing. Or you can call open circuit voltage gain one more name. Suppose asked on the gate you can write open circuit voltage gain. Any name allowed, voltage gain. What is A suffix capital V? A suffix capital means external voltage gain. This is called as a external voltage gain. Don't neglect these questions. These questions are also very important gate point of view. Circuit given means it is a voltage amplifier. You may ask this question or you may ask this question. Number of questions are there in these circuits. The information regarding the voltage amplifier. You may ask any question in the gate. Please note down this. Please note down this. Now, I want to give the current amplifier because you have to understand every amplifier now. You may ask any question in the gate. Current amplifier I want to take now. If it is a current amplifier, you can do it like this now. You may ask any question in the gate. Repeatedly asking. Repeatedly I say. But this amplifier is to be drawn, amplifier equivalent circuit I can draw. Input must be nodens and output must be nodens. Then only I can say it is a current amplifier. I can draw like this. You will have the current source IS. Asking questions, these model asks in the gate. Must be connected parallel, the nodens. This is RS. The resistance is to be taken as a RI. This is RI. In the nodens, you have to give importance to the current that you can put later. Now, this is anyhow, we have to give importance to the current. This is I suffix I, input current. This must be nodens, I said now. Nodens equivalent circuit is must this side. Nodens means current to this direction. In this direction, we need to draw. This current depends upon this circuit. In this circuit, current I suffix I is there now. It depends upon I. This is to be multiplied by A suffix small I. And resistance R naught is a must. And you must connect a load resistor here. Must be connected with RL. It is a nodens. This current is to be taken as a I naught. Suppose you are given this network, you are asked to identify the name of the amplifier. Easily you can say input is a non equivalent circuit, output is a non equivalent circuit, so it can be said as a current amplifier, very simple. Sometimes in the gate asking Ri is greater than Rs, Ri is a far more less than Rs, R0 is far more greater than RL, R0 is a far more less than RL. You may ask any question in the gates, because easily you can get from these circuits. But in the non-equivalent circuit, current is given much importance. This must be required more. If you want to get the current of the more, the resistance must be maintained smaller value. This must be smaller value. Then only if it is a less resistance, high current, more current will flow. This side less current required. Less current required means Rs must be more required. Then I can write Ri is far more less than Rs is possible. This is also important gate point of view. And sometimes in this case, R0 is far more greater than RL, R0 is a far more less than RL, you will give. In this case, in the non-equivalent circuit, just now I said current must be more required, RL must be smaller value required, R0 must be more required, must this condition. And easily you can write R0 is here far more greater than RL value. The condition is very important, asking repeatedly these model questions. Ri must be far more less than Rs, R0 must be far more greater than RL required. Sometimes you may ask, but here what is AI, you will ask, current gain, internal current gain equal to how much is asking sometimes in the gate. Internal current gain is required means non-equivalent circuit. You find I0 by applying the current divider formula. I0 means AI into II, current division formula, R0 by R0 plus RL I can write. R0 plus RL is required. But I want I0 by II. Sometimes asking I0 by II equal to how much? No problem. I0 by II you are asked means you can say this option is correct. This value is correct. R0 plus RL is possible. So if you are asked to find out the I0 by II from the current amplifier, that value is this much only. I0 by I suffix I is given a name A suffix capital I. This is required. You need to know every formula. No need to memorize, just circuit you draw and get answer in the gate. Internal current gain is required. Suppose internal current gain means A suffix I required, small I. AI into, if R0 is divided 1 plus RL by R0, that is to be multiplied by how much? A suffix capital I. If you are asked to find out the internal current gain, this is the formula. Asking questions like this only now. Internal current gain for the current amplifier is AI this much value. So A suffix small I is given a name internal current gain. Internal current gain. Or short circuit current gain. Short circuit current gain. Any name allowed. All these points must. All these points are must. Current gain required. But A suffix capital I is nothing but external current gain. External current gain. Maybe asking sometimes these questions now. And other two also I will explain, you will get the clarity. And next one is nothing but the trans resistance amplifier I want to take here now. Trans resistance amplifier. All four required. You may ask any question. Trans resistance amplifier. Because These are all very important questions only. That's why I'm doing, otherwise not required. The trans resistance amplifier means input must be Norton's equivalent circuit, output must be Thevenin's, I said now. Input must be Norton's IS. This must be connected with RS. This must be connected with RI. Must. If it is a Norton's equivalent circuit, you will give importance to the current I suffix I. Just now I said. But output must be what? Thevenin's only for trans resistance. Thevenin's means it is required voltage source. This depends upon this current I suffix I. Trans resistance means R suffix M. R suffix M into II. Rm means internal trans resistance. Internal trans resistance into current is a voltage only. Output must be Thevenin's, I said. This must be R naught. This must be RL. It is a repeated question in the gates. R naught and RL. R naught and RI values asking from the trans resistance and trans conductance amplifier. You know very well in trans resistance amplifier, current must be more required. RI must be smaller value required. RS must be more required. So you can write directly RI is far more less than RS. Very, very, very important points. Asking sometimes in the gates. But it is a Thevenin's only. In the Thevenin's, you will give importance to the voltage. Voltage must be more required means RL must be more required and also R naught must be smaller value required. In that case, I can write R naught is far more greater than RL value only. R naught is far more less than RL value. This is very, very important. RI is far more less than RS. R naught is far more less than RL required. Sometimes you will ask to find out the internal trans resistance. Internal trans resistance, this is the Thevenin's equivalent circuit voltage division formula you can apply directly. Rm into II into RL by R naught plus RL I can write. R naught plus L. You can check the question papers. So many times repeated questions all these. But a V naught by II is nothing but, sometimes you may ask V naught by II equal to what for the trans resistance sampler, V naught by II. Then that value is nothing but Rm into RL by R naught plus RL I can write. But a V naught by II, I will take it as a R suffix capital M I want to denote. So suppose you are asked R suffix capital M. This is required. V naught by Vi, if you are asked, this is the formula. In case you are asked to find out the R suffix small m, if you are asked in the problem Rm, options you will find 4 options now. Just you do analysis like this, you will get it. In 2 steps you are getting answer. It doesn't take more time. Rm equal to what? RL is divided by RL, 1 plus R naught by RL, 1 plus R naught by 1 plus R naught by RL into R suffix capital M. This is R suffix small m I can write. Asking these questions also. But here we know very well R suffix small m is given a name internal trans resistance. Trans resistance. But R one more name you know very well. I will not give here now. And R suffix capital M is called as a external trans resistance. Trans resistance. These are all very important here. Still left one more question. That also I will complete. You will understand clearly. One more question is there now. What is one more question here now? Transconductance amplifier is required. Transconductance, last one. Transconductance, this is also repeated question in the gate. But R naught and Ri values asking in the gate repeatedly. That is why here also very important now. But R0 and Ri, if you want again, just draw the circuit, you will get it easily now. No need to memorize anything now. But input must be Thevenin's, I said, in the transconductance amplifier. Input must be Thevenin's. Vs, this is Ri, sorry, this is Rs, this must be Ri. If it is a Thevenin's, you must give importance to the voltage Vi. This must be given importance to the voltage. But output must be Norton's equivalent circuit, I said. In the Norton's equivalent circuit, it depends upon the voltage. Voltage is to be multiplied by Gm, small m. Conductance into Vi is nothing but the current. And this is connected parallel to the R0 and connected parallel to the load. For the Norton's, you will give importance to the current. This is I0 or IL, your wish, I0 or IL. From this circuit, you can see, you can give the points like this now. It's a very important transconductance also. In Thevenin's, you will give importance to the voltage. Voltage must be more required, Ri must be more required, Rs must be smaller value required. In that case, directly we can write Ri is far more greater than Rs. Very, very, very much repeated question this also. Repeated in the gates. And here current must be more required in the Norton's. Current required more M means RL must be smaller value, R0 must be higher value. Very simple. And R0 is far more greater than RL value requires. These 2 points very, very important. Repeated questions, this. But sometimes you may ask to find the GM or I0 by Vi, any question you will ask. Current divider formula applied to find the GM. I0 equal to, you know very well. According to current division formula, GM into Vi into R0 by R0 plus RL. R0 by RL. Here I can take directly I0 by Vi. I0 by Vi I have taken as a G suffix capital M. So I will get Gm into R0 by R0 plus RL. This is G suffix capital M. If you are asked to find the I0 by Vi, if you are asked this formula, you must. This answer is correct. The last one, G suffix capital M. If you want to find the G suffix capital M, R0 you divide 1 plus RL by R0. 1 plus RL by R0 into Gm. This is the internal transconductance. Gm is nothing but internal transconductance. Internal transconductance, and a G suffix capital M is external transconductance. So all these 4 analysis questions are very, very, very important gate point of view. But up to this extent, you followed very well, I hope. Understand now. And next one, yes. If any students are willing to take the admissions in IMS Gate Academy, they need to know well about the program futures. They want to remember the 800 plus hours of the live classes with live interaction is possible. And theory books, exercise books will be provided by IMS Gate Academy. The exercise book contains more than 4,000 questions now. That book contains the 3 level questions, level 1, level 2, level 3. But those questions, if you did quite okay, it's not required other than this book for the preparation of the gate, I hope it now. Understand now. And also 34 plus years of the gate question banks with video solutions possible now. That means gate question bank will be provided by the IMS Gate Academy But those questions are solved with 2 or 3 methods only now. And also video solutions also provided and key points also given here now. 12 personalized one-to-one mentorship sessions possible now. That means in the mentorship session, the faculty is going to interact with the students and they are going to advise what way the preparation is to be made for the gates. Understand? 130 plus online tests with video solutions of the mock test and any more. But if you want to get any information, just they can call to this number and they can get the information regarding the gate. Understand my point now? Next one. Yes, the test series plus. But for this limited period, offer also given. Get 20% off test series plus only now. If anybody has taken test series plus, what benefits? 130 plus online tests, 33 years GATE PYQ books, technical subjects, 33 years GATE PYQ books, maths, general aptitude, doubt solving portal. In IMS GATE Academy, you can have the whatnot doubt portal session. The students are facing any problem while doing any questions to think it so. Immediately they can take the snapshot and they can post it in the doubt portal. Within 24 hours, they are going to receive the solution only now. Every faculty is ready to give the solution very perfectly. They are going to satisfy the students. Understand? Every problem will be solved in time. The doubt portal is a very good, very good one. It is advantage for the students only. Online revision and score booster, post-gate guidance and PSU MS mock interviews possible here now. The next one. Yes, the students can join in the Telegram channel. If they are joining in the Telegram channel, what are the benefits possible? Schedules of the free YT lectures and lectures PDF, important updates related to the seminar and webinar possible. And PSUs and another government job notifications possible. Expert sessions on important topics, daily quiz and many more possible here now. So if anybody wants to join, link is given in the description. Understand now? Okay, I hope so far you followed very well the subject. You enjoyed it more, I hope it now. You practice same questions again and again. It is still best only now. Thank you.